Okay, welcome back. Let's go ahead and finish out these problems. And I want to graph this quadratic function here. Now, the first thing I notice about this quadratic function is that this is in vertex form. So what I can find, okay, on my vertex is this. So my vertex is going to be the point 2, 1. All right, and I'm getting that from this 2 here and this 1 here. All right. So remember, this is going to shift the graph over 2 units to the right and up 1 unit. My leading coefficient is 1, so A is equal to 1, so we're going to open up. Okay. The next thing I want to do is determine a Y-intercept. Okay, so when my Y-intercept can be determined by the following. I'm going to let x equals 0, all right, and plug that in. So I'm going to do f of 0, plug that in. I'm going to get 0 minus 2 quantity squared and then plus 1. So f of 0 is going to give me negative 2 squared plus 1. If I take negative 2 and square it, all right, we're going to get 4 and then plus 1. So f of 0 is equal to 5. All right, so I got a couple points here. I got the point 2, 1, which I'm going to graph. So 2, 1, all right, that's that vertex there. And then I have the point 0, 5. So 1, 2, 3, 4, 5, plot that point. Now, the other thing that I know about this is that we are symmetric, all right? We have a line of symmetry down my parabola, okay? And the other thing that I know is that because my leading coefficient is 1, all right, I'm going to go to the left from my vertex, okay? Here's my vertex. I'm going to go left 1, up 1, okay? And that's the standard thing when A is equal to 1. Same thing over here. So all those points are going to be symmetric on the other side. So I've got the point 3, 2, okay? And then I've got the point 4, 5 as well. All right, and that's by far enough points for me to graph this, but, just want to make sure that what we have is a couple of points. So, vertex is the point 2, 1. Another point on this graph, another point. So let's do a point, that would be the point 0, 5. Okay, and we can talk more about, how to generate these other points in class and how this number A kind of affects that. All right, let's look at the next page. Okay, on this page, we want to graph the quadratic function f of x equals negative x squared plus 4x plus 1. We would then want to use the graph to identify the function's domain and its range. So this problem is in standard form, okay? This is in standard form, not in vertex form, okay? So remember, standard form, we use this concept of ax squared plus bx plus c. All right, and remember what we learned in the first video was that we can find the vertex from standard form. So the vertex, remember that x is equal to opposite b over 2a. And that's the x value. The y value is equal to f of negative b over 2a. All right, so that's what I'm looking for. So here's what we can do. All right, let's just take a look at this, and let's do the following. Let's find the vertex. All right, so let's first identify our a value is negative 1, b value is 4, and our c value is positive 1. Okay. So we can tell a couple of other things, but let's just first find the vertex of what we have. So my vertex is going to be, and let me just write this over here, x is going to equal opposite 4, okay, opposite b is 4, over 2 times a, so 2 times negative 1. All right, so now I've got that x is equal to negative 4 over negative 2. And then I have that, so then I get that x is equal to 2. All right, so that's the x value of my vertex. Now what I want to do is plug this value in. Okay, so my y value, remember, I'm going to plug in f of 2. Okay, so that's going to be negative quantity 2 squared, okay, plus 4 times 2, and then plus 1. Now, the tricky part with this one is that you had a negative x, okay? Now, you know, that's like a negative 1 outside of the x. So remember, you have to square this before you multiply this by negative 1. Okay, so that's kind of a tricky little thing there. All right, so now let's do this. Let's go ahead and do negative 2 squared is 4, so negative 4 plus 8, and then plus 1. All right, so I'm going to get negative 4 plus 8 is going to give me 4 plus 1, and that's going to give me 5. So f of 2 is equal to 5. And this is my vertex, okay? And so what I can find from my, that translates to the point 2 comma 5. All right, remember that anything in function notation like that is just a point on the graph. So I'm going to do that. I'm going to plot 2, 5. All right, so let me come up here over 1, 2, 1, 2, 3, 4, 5. Okay, I'm going to plot that point, and that is my vertex. Okay, so the other thing that I want to do to graph my functions, let's find our y-intercept, okay? So y-intercept, we can do that. We just want to let x equal 0, okay? So I'm going to plug that into the function. I'm going to find f of 0, and I'm going to do, so I got negative 0 squared plus 4 times 0, and then plus 1, okay? So I have the point f of 0 is equal to 1, all right? So that is my y-intercept, all right, is the point 0, 1. Okay, now remember that, when we graph these points, that these are going to be symmetric. My vertex here is my line of symmetry. Okay, so my line of symmetry does this. All right, so now, since we're symmetric across that line, okay, I can plot another point over here that's 2 units over. Okay, because my a value equals negative 1, all right, and so let's do this. A equals negative 1. That means the graph is going to open down. And, okay, the other one was a equals 1, it opened up. All right, so this one opens down. And because we have a multiplier of 1, we're still going to follow that same thing, that from the vertex, we're going to go to the left one and down 1, from the right one and down 1, okay? And that's just standard when we have that. Now, what I want you to also notice here is that our x-intercepts aren't readily solvable, okay? So those are our x-intercepts, all right? So we have, the x-intercepts here that are going to be values in between 0 and 1 and in between 4 and 5, okay? And that's okay. And the reason why I'm not finding the x-intercepts is simply because these are going to be, kind of some hard numbers to find. Okay, we can still find them, but I don't want to do it right now. Okay, but what I do want to do is I do want to just at least label the vertex. Okay, and then like another point, the y-intercept. Okay, and we can label the x-intercepts on the graph, but we don't need to, actually plot those points. All right. But that's how we graph, all right? And so, just to recap what we just did, we're finding, the vertex using x equals opposite b over 2a, finding that x value, plugging that x value back into the function, okay, to generate our y value, which was 5. And then we can always find our y-intercept, okay? That's always another point that we can find. And then we make sure that the graph, we're doing it correctly by making sure that it's opening down because a is negative, okay? And so that's kind of how we do it. We could also find the x-intercepts, but depending on what a is and depending on what the graph looks like, you may or may not need to do that, all right? So, all right, let's go ahead and take a look at the last one. Okay, on this one it asks, using the quadratic function f of x equals 4x squared minus 16x plus 1,000, determine without graphing whether the function has a minimum value or a maximum value. So the first thing I want to do is recognize that this function is in standard form. Okay, and so that's the first thing. What I want to do is identify my a value, my b value, and my c value, just so we have them. Okay, so I got 4 is my a value, b is negative 16, and my C value is 1,000. Okay, so in part A, all right, it wants to know, do we have a maximum value or a minimum value? So what I want to do is look at my A value. Okay, A is equal to 4, okay, which means that A is greater than 0. So that means that the graph is going to open up. All right, so we're going to open up, which means that we're going to have a minimum. Okay, your graph is going to look like this. So what this means is that down here, okay, you have a minimum. All right, okay, and you don't have to do all that work. I mean, I would, if you're going through this class and you're like, okay, do I have to write down all this stuff? No. If you understand it, okay. If you don't understand it and you need to go through and go, okay, A is equal to 4. A is positive. That means it opens up. Draw the picture. That means I have a minimum, okay. You can do that, all right. But if you just understand how that looks in your head, then you can just write out, we have a minimum. All right, so now in part B, it wants us to find the minimum or maximum value and determine where it occurs. So what I want to do in part B, okay, is find, all right, x equals opposite b over 2a, and then do f of opposite b over 2a. So x is equal to opposite b, which is positive 16. Okay, b was negative 16, so the opposite of negative 16 is positive 16, over 2a, so 2 times 4, okay? And what that's going to give us is the value 16 over 8, all right, which is going to give us the value of 8. So x is equal to 8. Now what I want to do is, I'm sorry, this should be 2, not 8. Idiot. Gah. All right, so x is equal to 2. All right, 16 over 8 is 2. All right, I'm making my mistakes. You guys know me. All right, so now let's plug that value into our function. All right, so I'm going to do f of 2, and that's going to equal 4 times 2 squared minus 16 times 2, all right, and then plus 1,000. All right, so here's what we're going to get. So f of 2 is going to equal 4 times 4 minus 16 times 2 plus 1,000. All right, so that's going to give me 16 minus 32 plus 1,000. So 16 minus 32 is going to give me negative 16. All right, so we get negative 16 and then plus 1,000. So if I subtract 16 from 1,000, that's going to give me 984. So f of 2 is equal to 984. So my vertex, okay, and this is my vertex. All right, my vertex is the point 2, 984. Now, because my graph, remember, because a is greater than 0, and we open up, all right, this is going to be my minimum. Okay, now my minimum point is a little bit interesting. When we talk about a minimum value, all right, so a minimum value is a y value, okay? So our minimum value, so our minimum is 984, and that occurs at x equals 2. Okay, so that's how we can write that. All right, so our minimum value is the y value. All right, and we want to identify the function's domain and its range. So the way I can do that, anytime we have and I need to do that in the problem above. We didn't even do that. Our domain in part C, okay, any quadratic, your domain is going to be from negative infinity to positive infinity. But remember that, if I just do a quick little graph of this, and I do 2 and then 984, okay, remember that this graph opened up. All right, so we can calculate our range simply by knowing that information, okay? And I'm not like graphing this and getting anything exact. I'm just simply drawing a quick little picture. But what I do know is this, is that our minimum value is going to be 984, and then we go to positive infinity, okay? And that's my range. We need to go back up here and do the domain and range here. Remember that our domain, D, it goes from negative infinity to positive infinity. That's true for all quadratics. But our range, Okay, remember our y value, maximum y value is a 5. All right, so our range goes from negative infinity to positive 5 and draw a bracket. Okay, and that's that. So that's what I've got for this. Hope you enjoyed the video, and we'll see you soon. Thanks a lot. Bye. Okay, on this problem, we've got this problem where an archer's arrow follows a parabolic path. The height of the arrow, f of x, in feet can be modeled by f of x equals negative 0.005 x squared plus 2x plus 5, where x is the arrow's horizontal distance in feet. So it says, what is the maximum height of the arrow and how far from its release does it occur? So in part A, it just wants us to find the vertex, okay? So what we're going to do is identify our A value, our B value, and our C value. So A is equal to negative 0.005, B is equal to 2, and C is equal to 5. So what I want to do is find x, the x value at which we have a vertex, and that's x equals opposite B over 2A. So what I want to do is plug these values in. So I'm going to get x is equal to opposite B, so minus 2 over 2 times negative 0.005. So what that's going to give me, x equals negative 2. 2 times negative 0.005. So 2 times 0.005 is going to give us, it's going to be negative 2 over negative 0.01. Now, when I take 2 and divide it by 0.01, okay, well, it's going to give us 200. Now, what we're going to do, this is going to be positive because a negative divided by a negative is positive. So this is 200 feet, horizontal feet. Okay, now what I want to do is plug that value into my function. So I'm going to do f of 200. Okay, plug that in, and we're going to get negative 0.005. Quantity 200. Let me make some more room. Okay. So, sorry, running out of room here. All right, small. F of 200 is going to equal, what do we got? All right, so we got negative 0.005 quantity 200 squared plus 2 times 200 and then plus 5. So if I take 200 and square it, so 200 times 200 gives me 40,000. Multiply that by 0.005 negative. That's going to give me a value of negative 200 plus 2 times 200 is 400 and then plus 5. Okay, and so what we're going to get is going to be negative 200 plus 400 gives me 200 plus 5, and that gives us 205 feet. Okay, so that's what happens when we plug in 200. So here's what we've got. So our horizontal distance, make sure you guys are writing small. I'm not zoomed out far enough. Our horizontal distance is going to be 200 feet. Okay, our maximum height is going to be 205 feet. Okay, and so that's what we're doing. All right, and if we just kind of like think about what the graph is going to look like, all right, here's 200. Okay, and then, you know, our maximum height is 205. Okay, now the next thing that we want to do is we want to find the horizontal distance the arrow travels before it hits the ground. Okay, now what I want to do is when it hits the ground, okay, so part B, so the arrow hits the ground when the height, f of x, is 0. Okay, so what we're going to do is this. I'm going to set 0 equal to negative 0.005 x squared plus 2x plus 5. Okay, and what I notice about this is that, you know, in this problem, you know, if I'm solving a quadratic like this, I want to use the quadratic formula. Okay, so I know that my a value is equal to negative 0.005. My b value is equal to 2, and my c value is equal to 5. So what I want to do is use my quadratic formula, x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, and then I'm going to get opposite b, so negative 2 plus or minus the square root of b squared, so 2 squared, minus 4 times negative 0.005 times 5. Okay, all over 2 times negative 0.005. All right, so as a result, what I'm going to do, and I'm way off the page, so I apologize about that, guys. So x is equal to negative 2 plus or minus the square root. So 2 squared is going to give me 4, okay? And then I've got negative 4 times negative 0.005, so 4 times 0.005 is going to give me 0.02. Multiply that by 5, and that's going to give me 0.1. So I'm going to get 4 plus 0.1, okay? And then divide that by 2 times 0.005. That's going to be negative. So that's going to be negative 0.01. All right, so then here's what I'm going to get. I'm going to get negative 2 plus or minus the square root of 4.1 all over negative 0.01. So the first thing I want to do is this. Here's my answer. It's not going to be nice and neat. All right, however, what I can do is I can do, let's do this, negative 2 plus the square root of 4.1 over negative 0.01. Okay, and then let's find negative 2 minus the square root of 4.1 over negative 0.01. Now, I need to do both of them because one of them is going to be over here. All right, I'm going to have 2 solutions here, but I'm looking for the one that's going to be positive, okay, because that's when it's going to hit the ground. All right, the other one is going to be negative because we have a y-intercept of 5, and that's going to go that way. All right, so let's come down here, and let's plug this into the calculator first. Okay, so I plugged this one into the calculator. I just used Desmos to do that. And so I get x is equal to negative 2.48 feet, okay, which is going to be the one that we're not going to use, okay? So let's do the other one, and let's do minus. And that's going to be that x is equal to 402.4845 feet. Now, they wanted us to round to the nearest foot, okay? So, since we're dealing with a 0.4 here, the nearest foot is going to be this place value. So I look at this number. Because that's less than 5, we're just going to have 402 feet. And that's our answer for part B, okay? Let's take a look at the last one. You have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? So what I want to do here is I want to draw a picture, okay? I'm just going to draw a generic rectangle. And I've got this. I'm going to do X and Y, okay? And I know that my perimeter is going to be 120 feet, okay? And so what I want to do on this is I want to write out, my perimeter formula. So my perimeter formula is going to be 2x plus 2y. I'm going to plug in 120 into that. So I've got 120 is equal to 2x plus 2y. All right, that's the first thing I need to do. Now, the next thing I want to do is I have an area formula, and that's going to be x times y. This I want to maximize. Okay, so what I'm going to do is I'm going to take, use my equation here, solve for one of the variables, and obtain a value that, get and plug it into here. So watch what I do. I'm going to solve this equation for y, okay? And what I'm going to do is I'm going to subtract 2x from both sides, okay? and I'm going to get 120 minus 2x is equal to 2y. I'm going to divide both sides by 2, divide everything by 2. So we get 60 minus x is equal to y. Okay, now what I'm going to do is I'm going to take this value and I'm going to plug it into y of my other equation. And what I'm going to get is this. Area is equal to x times 60 minus x. Okay, now if I distribute my x here, all right, I get area is equal to 60x minus x squared. Okay, now this is a formula. This is a function for area, depending on what my length x is. Okay, so I've put this in terms of x, and what I want to do is I want to maximize this. Now, the first thing I'm going to do is rewrite it as negative x squared plus 60x. Okay, and I'm going to find the maximum. Now remember, I have an a value, I have a b value, and I have a c value here. A value is negative 1, b value is 60, c is 0. So what I have, x is going to equal opposite b over 2a. So x is going to equal opposite 60 over 2 times negative 1. And so what's going to happen is I'm going to get x is equal to negative 60 divided by negative 2, so x is going to equal positive 30. Okay, and now what I'm going to do is I'm going to plug that into my area. So that's the dimensions. All right, that'll give me the dimensions. All right, so hold on. Let's find the area first. So my area is going to equal 60 times 30 minus 30 squared. So area is going to be 60 times 30, so that's going to give me, I want to say, 1,800. Okay, so 1,800 minus 30 squared, so 30 times 30 is 900, so minus 900. So my area is going to equal 900 square feet. Okay, this is going to be my maximum area. Okay, so that's my max area. All right, now what I want to do is to find the dimensions of this. And so I know that y is equal to 60 minus x, okay, from this up here. And I'm going to plug in 30. So I know that y is equal to 60 minus 30, which is 30. Okay, so what we've got is we have a rectangle. So my dimensions are going to be a 30 by 30 rectangle. So 30 feet by 30 feet. And we'll have a maximum area of 900 square feet. So that's what I got for that. So sorry I wrote off the page all over here. You may want to grab another piece of paper. I didn't realize it was going to be that long, so I apologize. So we'll see you in a bit. Thanks a lot. Bye.